Assalamualaikum, ini presentation lab 5 kami. Ini members group kami, Daniel Arshad, Dinesh dan Darwinesh. Input and output devices and its function in the computer system. Belah kiri ada input, belah kanan ada output. Okay, for devices in input ada keyboard, mouse, microphone. For output device, monitor, printer and speaker. Untuk input, device dia directly connected to the PC. Output dia indirectly connected. Okay, keyboard punya function, device used to enter text, commands and other data into a computer. Mouse punya function, pointing device that allows users to interact with a computer by moving a cursor. Microphone, device that converts sound waves into electrical signals, allowing users to record audio or communicate in real time. Monitor function, device that displays virtual information from a computer. Printer function, produces hard copies of digital documents, images or graphic. Speaker function, it's a device that convert electrical signals into sound waves. C program that takes a name and age as input and displays a greeting message. Jadi ini ialah C program kami. Pseudocode to represent how the CPU checks if an I/O device is ready before transferring data. Start and repeat read status register from I/O device. If status register indicates ready, then proceed to transfer data. Exit loop. Else wait briefly, and if until device is ready, transfer complete, and how this method affects the CPU efficiency. Inefficient because the CPU continuously checks the status of the I/O device, consuming processing cycles even when the device is not ready. This means the CPU is occupied with unnecessary checks instead of executing other tasks.
So, this is our scenario. A printer is connected to a computer system, just like the image shown beside. So, when the CPU sends data to the printer, which means when a user gives instructions to the CPU to print any documents in the computer, the printer takes time to print and is busy during this time. So, once it finishes printing a page, it sends an interrupt signal to notify the CPU that it is ready to receive more data. So, this is our sequence diagram. First of all, the CPU sends a data block to the printer. Then, the printer begins printing. After that, CPU continues executing other instructions which is not related to the printer. When the printer finishes printing, it sends an interrupt signal to the CPU. So, the CPU stops its current task, saves its states, and jumps into the interrupt service routine. Interrupt service routine handles the printer's interrupt. For an example, it sends the next block of data. Then the CPU restores its previous state and resumes its interrupted task. Lastly, we are going to look at the comparison between interrupt-based I/O and programmed I/O. Looking at this comparison table, we can conclude that the interrupt-based I/O is way more better than the programmed I/O. For an example, the interrupt-based I/O has a more efficient CPU usage compared to the programmed I/O. It is because its CPU can execute other tasks while waiting for device interrupts. Meanwhile, the programmed I/O CPU repeatedly have to check on the device status. Also, the interrupt-based I/O has a high responsiveness because the device immediately notifies CPU as soon as it's ready. It also has a lower energy consumption and does not require polling.
Hello everyone, today I'm going to explain DMA concept introduction. And yeah, DMA is a direct memory access. It's a system employed in computers making the device's input output is a IO such as a disk drive or a network card able to send data directly to or from the memory without the CPU having to mediate through the entire move. And the CPU, under normal circumstances, reads data in the I/O device and writes the same in memory. This action may make the CPU slow, and also DMA eliminates this because of the existence of DMA controller that replaces the data transfer process. The CPU simply informs the DMA controller of what to do, such as where to store the data and how many of it to transfer, and then the DMA controller take it beyond. Yeah, this is the basic diagram of DMA, which is the CPU, memory, DMA controller, and also the I/O devices. Let's see how data is transferred without CPU intervention. Firstly, CPU sets up the DMA controller. It tells the DMA controller the memory address to use. Also, it gives the I/O device address, and it specifies the number of bytes to transfer. Second, direct memory access takes over. The CPU is free to do other tasks, and also the DMA controller controls the data path between the I/O device and memory. Thirdly, transfer occurs. DMA controller reads from or writes to memory directly. Also, the CPU is not involved during this process. And lastly, interrupt sent to CPU once the transfer is complete. DMA controller, which is direct memory access, sends an interrupt to notify the CPU.